A ground fault is an unintentional grounding of an insulated wire. What can cause a ground fault? A nick or cut in the insulation. A poorly repaired splice with water around it. A current must have a path to an earth ground to be a detectable ground fault. In most cases, a cable contained in a conduit will not have a detectable fault to ground. One exception would be a PVC, non-conductive conduit that is completely severed, exposing the conductors to the earth ground. A ground fault locator uses a high voltage signal to detect the location of a ground fault. The locator sends the signal down the wire and it exits at the fault and enters the earth. The signal then returns back to the ground stake. The ground fault locator uses this returning signal to pinpoint the fault. We will demonstrate this process using the Armada Technologies GFL 3000 ground fault locator. The GFL 3000 is designed to pinpoint the exact location of a ground fault in a cable. The GFL 3000 is not intended to locate the entire path of a cable. To effectively pinpoint the location of a fault using the GFL 3000, the path of the cable must be previously determined and the wire must be in direct contact with the earth. To demonstrate that the path of the wire has been previously determined, the wire has been placed above ground. The fault is illustrated with a flag for further clarity. In cases where the wire is contained in conduit, the conduit will interfere with the locator signal and not result in an accurate reading. Isolate the cable to be tested by disconnecting it at both ends. Make sure the cable is disconnected from power, components, or anything else that could transmit an electrical current. This forces the current generated by the transmitter to exit the cable at the fault. At either end of the cable, and with the transmitter off, connect the black lead to the ground stake and push the stake into the ground as deeply as possible. Connect the red lead to the cable that is being tested. Note that if the clock is indoors, the black lead must be connected to its own ground stake where the wires exit the building. Do not use existing grounds in the building. Before turning on the transmitter, be sure no one is touching the stake, cable, or leads. When turned on, the transmitter will produce a beeping sound indicating current is being transmitted. Select low or high power as per your preference. High power will find all leaks, large or small. Low power will concentrate on larger faults. Remove the black insulating covers on the probes of the receiver. Turn the receiver on and place the receiver probes into the ground along the path of the cable. As the transmitter pulses the current, you should see the needle on the receiver kick in the direction of the fault. Watch for the direction of the initial kick of the needle and disregard the rebound kick. Remove the A-frame probes from the ground and move it in the direction of the initial needle kick along the path of the cable. Reinsert the probes into the ground and observe the direction of the initial needle kick. Continue down the path of the cable in this manner until the needle kicks in the opposite direction. This indicates a fault is between the last two places the receiver probes were inserted. Continue to zero in on the fault by following the initial needle kicks. When you are directly over the fault, the needle will cease to kick. Mark this spot for repair. Before repair, turn off the transmitter and disconnect it from the cable. Never touch the transmitter, leads, or the cable being tested while the transmitter is on, and do not use the transmitter in the rain. Failure to follow these precautions could lead to injury or death.